Right here you can see every component involved in the evaporative emission system. The job of the system is essentially just to limit the amount of fuel vapor that can get straight into the atmosphere. So vapor from the tank is stored in the canister until it can be put back into the engine and burned. The canister is purged by putting fresh air through it and into a port on the intake manifold. That vacuum is controlled by the EVAP canister purge valve, which operates whenever the engine coolant temperature is above a certain temperature, typically about 150 degrees. Whenever the vapor pressure in the tank is higher than the set value of the valve, the EVAP valve, then that valve will open and allow fuel vapor to go into the EVAP canister. And finally, when you refuel, the fuel tank vapor control valve is responsible for opening when the pressure in the fuel tank reaches a certain point, and then it'll feed that vapor into the EVAP control canister. Honda has quite a few codes for the EVAP system, but we're going to be looking at P1456 and P1457. If we take a look, there's two separate procedures that Honda has depending on the vehicle. We're going to be using procedure A as it applies for the Odyssey, whereas procedure B applies for Civics and CRVs. But here it gives you an entire diagnostic tree, starting with checking the fuel tank pressure, and then from there checking the fuel cap, the bypass connect valve, and I'm not going to read everything on here, but as you can see, it's a very extensive list with very well drawn diagrams that go through exactly what you should check, what it looks like, and how to hook everything up. Using ALLDATA alone, I wasn't able to find any information about the evaporative emission drive cycle, but I found somebody else who had a complaint that they've driven their Odyssey on, they haven't gotten it to pass the smog, so there's a very detailed step-by-step. It's very specific here, so I'll go over some of the key points. You need to be at a cold start, it has to be below 122 degrees Fahrenheit for the coolant temp, and within 11 degrees of the outside air temperature. You have to idle it for 2.5 minutes with the AC on as well as the rear defroster. Then after that you have to turn off those pieces, drive it at half throttle until 55 miles an hour. Then from there the O2 sensor is going to read. After that you decelerate, but you don't shift down manually or step on the brakes, trying to get down to 20 miles an hour. At that point you accelerate at 3/4 throttle until 55 miles an hour is reached. Those same tests are then run again. You hold a steady speed, and then the ECU takes a look at the catalytic converter. So, given those very specific conditions, it's interesting that the vehicle is able to run just here in the lab at idle and perform all the different tests. One of the pieces it said to check for was making sure the FTP sensor was in between around 2.1 to 2.7 volts. As you can see, we're within that range, so we should expect to pass that part of the scan. As I'm going through that scan with the snap-on tool, I had a SRS airbag light that was on previously, but now it's being replaced with a check engine light, I presume just as it's going through its different procedures. So the test came back, it said the evaporative system was normal. That being said, I've got my SRS code back, which is to be expected, but I've still got the check engine light on, but no codes are present with it. I went ahead, shut off the vehicle. I'm gonna see if I fired up if that check engine light's gone. Guess it's not. Since then, I went ahead and unplugged the scan tool, and now you can see when the vehicle starts, no more check engine light. But that's not just because the bulb's burned out. You can see the bulb still pops up before it disappears. It's important when working with these EVAP systems that you always use the proper gas cap. As you can see, this one here, the threads, those are very specific, and EVAP systems can detect up to 0.20 inches of a hole. So if you're using an improper made gas cap, that could easily cause an issue. Alright, so I'm going to show you guys the voltages and the duty cycle as I give it some RPM. Recently, this vehicle passed an Illinois emissions test. As you can see, the misfire monitor, all those other monitors were ready, except for the ones obviously that aren't supported. However, since then, I disconnected the battery, and it's a good thing I disconnected the battery afterwards, because you can see I still haven't gone through and completed some of the different cycles. The clips you're about to see are muted, which is why I'm explaining everything here. This is all going off of Mr. Heisner's slow fill concern document. Shout out to him for providing this for us. Essentially, they had an issue over at Ford where vehicles would come in with a slow fill concern. The pump would click off multiple times, so Ford developed a technical service bulletin to look at the fuel tank pressure sensor and measure the voltage, whether using a voltmeter or OBD2, to see if that increased by more than half a volt. It's expected to see some increase, but anything more than half a volt is bad. If you saw more than half a volt, could be spider webs or mud getting in or kinked tubes or any number of issues. So I know that obviously that was for Ford, but given that I have a fuel tank pressure sensor that I'm actually able to test, those are the clips that you're going to see and that procedure during a fill-up.
Enjoy smoke-free, spit-free